painful than it should have been, Ali. Sorry.
It's fine.
I don't know why that's so laggy. That hasn't happened to me before.
We are live.
Hello, everyone, and welcome to our webinar for today. And I'm Sheamus McGovern, and happy to host this event along with my colleague Ali. And just a few quick words about ourselves. So I'm Sheamus McGovern, founder of ODSC and head of AI at Cortical Ventures. And as you can see on there, I have a number of years experience both in the consulting field and the engineering field. I would say that's more like 20 years to 10 years. And I'll let Ali, if you want to introduce yourself as well.
Yeah, sure. Hey everyone, it's really good to have you. And yeah, I've been in the field definitely less than Seamus has been. It's 4 years in data and data engineering projects, and I've been working with Seamus on some other projects for the last 2 years.
Yeah, I can definitely attest that it's not the length of experience you need because I've been very impressed with working alongside Ali. And I think you've got way more than 4 years, given some of the stuff that we built in large language models in RAG. Yeah, so just some context here. Myself and Ali have been working on a number of projects together, and we've been fortunate enough to, I would say, be at the forefront of this new wave of AI, predominantly large language models and generative AI. So we've got to work with some of the top tools out there, including OpenAI, agentic AI, as well as Retrieval-Augmented Generation, RAG, which is what our talk is about today. So happy to answer any questions you may have about this, because again, this talk has drawn a lot from the experience we have. And we're going to spend about the first part of this session will be on RAG itself, just giving you a foundation in RAG. And also, we know some of the listeners and some people viewing this after the live session after the live session. Some of you are coming from this from a technical standpoint. Some of you are coming from a business standpoint. So we did want to show you actually how a retrieval augmented generation system is built. Like, how do you build one for a pretty basic use case that you can build upon? So Ali and I are pretty excited to bring you a code note that Ali has worked on, which is going to show you how to build one of these RAG systems and pull together the topics that I'm going to talk about in the tools. So yeah, and if since we're on StreamYard, if you want to introduce yourself, tell us where you're from. Always good to get some questions as well. So any questions you may have, let us know, because we're here to answer questions. So we want to kind of make it interactive as well. And also let me know if you have any difficulties with hearing echo or anything like that. So I think the first thing here is to set a little bit of context. So one thing we always get is maybe a little bit of skepticism around RAG, like, why do we need it? And if you've been in the tech space for the last 5-10 years or even longer, you'll know before RAG we already had search. This was called enterprise search, and these enterprise search systems were built on top of relational databases, RDBMSs such as Postgres, maybe Oracle, maybe Microsoft. You're also familiar with using data warehouses, data lake houses, and such to retrieve both your structured and unstructured information. And these systems were quite good in definitely in the case where there was nothing else available, in terms of if I had to look up a document, look up a keyword, where could I find anything? And they were built to handle these complex, nuanced queries. And we're quite familiar with a lot of these tools. So, for example, for the last 2 decades at least, Elasticsearch and also Solr have been two very powerful open source tools. Elasticsearch has a paid platform on top of that as well. But I would say these are two of the top enterprise search solutions out there. both for building platforms as well as building open source solutions on top of these. And that has been quite quite well used. And then, of course, you have databases still in use, and even with RAG, we still expect these to be used. So you've got your SQL, NoSQL, and these are good at retrieving structured queries. But one issue you have with databases is, despite SQL being built as a language for data analysts, it is a bit of a skill set to go and retrieve that data. And if you've ever used, I would say, PowerPoint or Tableau, you would realize after a certain amount of time, you would need to use some kind of query language to really become a power user in that. So user-friendly, I wouldn't call them to a certain extent. And then, of course, with NLP, the rise of NLP over the last 15 years, you've had some pretty simple techniques that we still use, such as TF-IDF, term frequency. It's still a model that Ali and I have used over the last year or two, where we're trying to figure out for a given documents, for a given set of documents, we want to know the most common words, the most common phrases. But what that lacked was any kind of context, and then BM25 is also known as well. Another thing we struggle with as well, because again, you'll hear me reference this a lot, but myself, Ali, and our colleague Sharif, and also Daniel, even with large language models, we've had to build up what we call taxonomies and ontologies. One use case we were looking at job descriptions across different job roles like data science and AI engineering, and we were trying to build up a taxonomy of what are the skills used for data science. And those taxonomies are pretty hard to build up, because sometimes a word sounds similar to a common word. It has lots of synonyms, lots of different meaning. Taxonomies are usually stale, meaning you build it up once and then you use that taxonomy, but what if things are changing, right? New skills, new platforms are being added. So those kind of solutions, while good, still have their challenges. And then, of course, we all know about document management systems. You might be using Google Docs, you might be using DocuStore or Dropbox or something like that. But document management systems, if you've ever tried to build one of those or get data from it, they're definitely better than systems that predated that. But still, there's a challenge there as well of getting access to this data. So this is why RAG has become such a hot use case, because all of these items around here have been around a while, but they all had their various issues and various constraints. And with retrieval-augmented generation, the promise there is we want to combine retrieval-based methods. And retrieval-based methods have been around like as old as computer science. They've been around quite a while. But we want to marry those to generative models to provide accurate contextual relevance responses. You can see here on the right, this is a prompt that you're probably used to using for ChatGPT or Anthropic or a similar service. And with these, you basically give it a prompt, and it goes based on the foundational model. It will give you a response or something like that. So what we want to do is marry this generative systems to retrieval-based methods. And what we're looking there for the most part is a query and response, right? So based on the query input, interpreted by a large language model, it searches and retrieves the relevant for the correct documents. And you might not be aware, but the main thing we're using here in our large language models is something called NLU, a natural language understanding. Can I take a query, understand that query, and then maybe in the back end, I got to convert that to some kind of code that will allow me to access a body of information. And once I get those results, I'm using something else from the generative AI and large language models, and that's NLG, natural language generation. So can I take those results in whatever format they were in, embeddings, query results, code results, and can I generate text from that NLG? So that's very important. And remember, those older systems, the two big problems they had was they were not good at NLU. They were not good at natural language understanding. You'd had to give it some SQL code or give it a code word, a phrase or something like that. And we'll find documents based on the phrase matching. And it definitely wasn't very good at NLG. You couldn't ask it, based on the retrieval results, draw me a graph or create an image or build a report or just give me the results of that in a kind of an email format. And this is why RAG is so powerful. An example of this would be a user query triggers information retrieval. The LLM is used for natural language understanding. Then we do our data query. We go and pull that data in. The relevant information is fetched and fed into a large language model. And then that relevant information, using natural language generation from the LLM, we generate a response. So this, in a few simple lines, is why RAG is so powerful. And yeah, so by the way, just guys, if you want to post questions here as well. I see a question from our other Ruken. Yeah, so if you want to post questions in the comments. I can tell you, when you post a question, we just show the question like this. Oh, a little bit of a lag. Why is it not showing the question? Yeah, so you can just post the questions in the chat right there if you have any questions around this. So this is really why retrieval-augmented generation is all the rage right now. And another question we always get is, especially if you're new to this, why would I use a large language? Why would I use retrieval-augmented generation versus, say, using something like the large language model itself? And that's a very good question, especially since things are moving so fast right now. So the first thing, and it's kind of hilarious to be saying traditional large language models as if they were years old. They're only a couple of years old in a certain context, but let's go with it anyway. So traditional large language models generate responses based solely on their internal training data, right, which can lead to inaccuracies or hallucinations. So what that means is these models were trained on vast amount of data at a certain time. If you ever go into ChatGPT, it will tell you something like, I don't know the answer to that. I was last trained in September 2022, right? And that is an issue in a lot of use cases because, well, what if I wanted newer information? And one thing to note is that ChatGPT and Anthropic and the rest, they're already coming out with web search. So I think I know last week ChatGPT released a new model that incorporates web search into it. But that only partially solves the problem because the key value proposition for RAG is that it can do real-time retrieval on information that is not included in the training. So, for example, let's say you have a customer, you're trying to build a customer agent, and it needs to use RAG to retrieve whatever that customer did, and that customer could have done something, could have created an order just 10 minutes ago, right? A large language model is not going to know about that because it wasn't trained up until 10 minutes ago, number one. Number two, a large language model does not have privy to your company's private information. That's the second big point. So those are two of the big reasons why RAG is very popular. So, and because it has access to more what we call ground truth information, it helps reduce hallucinations because it takes those foundational learnings and marries that information to what you give it in terms of your documentation. And it's not just about real-time documentation. Let's say you're a healthcare billing organization, or you do ad buys for advertising. You give it all the information that you know about your domain, about your industry, and that information can be used to improve the large language model responses. It's real time as I meant. And what that does, it gives us contextual relevance, right? Because large language models are trained on huge amounts of data. They have a lot of context. They have a certain foundation. But what you also need to do is contextual relevance to the use case you're applying it to. A favorite one of mine is real estate, right? There's luxury real estate. There's commercial real estate. Real estate is very geographically bound. and you need to be an expert in your town, in your location, in the given streets, in the given city. And a large language model out of the box wouldn't have that. And then the other thing here is compared to the traditional systems, if you ever use solar or something like Elasticsearch, you will notice that those are very much keyword or phrase based matching. So, and then last thing here is the idea here is we want to blend retrieval with generation for fact-based contextual awareness responses. So using the large language model to do the understanding generation and retrieve that. And last point is the most important one. General LLMs are not trained or fine-tuned to your data. Now you can actually fine-tune your LLM, which may make it better for a domain. So let's say you're using that healthcare example. You would fine-tune your LLM to be a healthcare LLM, but still it wouldn't have access to that real-time information and all that documentation that kind of comes with it. Another key point here is like contextual windows are getting very large. Like Gemini has 2 million tokens, which is about, I don't know, 3 or 4 book sizes of information, but most organizations have much more than that. And you don't want to be loading in 2 million tokens every single time because there is a cost to that. So let me take some quick questions here because I can see they're coming in hard and fast. Yeah, so we're first question here. I guess I can't display these questions for some reason. I'm not the main person, but the first question we have, if Sophie can display that, is from Peter. Can you discuss evaluation frameworks such as Ragus? Yeah, we're going to discuss evaluation, not that particular one, but other ones in a later slide. And Ali has some code on that. Microsoft Copilot 365, can that be classified as RAG? That's an interesting question. I never thought of that, but the way you could define it is RAG defined as Retrieval-Augmented Generation. So are you retrieving some documents? If you're giving an AI access to your emails or any kind of texts or information like that, then yeah, it could definitely be classified as a type of Retrieval-Augmented Generation system or your documents. I would say that would be the case, but I'm not sure because I'm not a user of, I use some Microsoft tools, but not that particular one. Victor is asking, can RAG be used with chatbots? Yeah, that's probably one of the most particular use cases. So imagine you had a customer support chatbot, where you're looking to, say, support a given use case. I'll stick with the healthcare one, right? Customer comes in, they're saying, I have an appointment scheduled for XYZ. Like that would probably go off to a system and look up a database because that's where you need factual information. But they may say like, let's say the chatbot was, I was given some optical care, and can you give me some advice on how do I deal with my eye care for the next 3 or 4 days? And it could retrieve some documentation, give an answer based on that, based on what the practice does that. So, and these chatbots, they're getting more sophisticated because, again, with some of the RAG systems we built, what Ali's built, and Sharif and Daniel, they're kind of like almost hybrid systems. They access documents, they access some agentic AI, and the chatbot would plug into that as well. So another question from Morelli is NLU and NLG an alternative to NLP? No, actually, NLU and NLG they are almost a part of natural language processing, and I know that's a big. But if you think of NLP, I think of NLP as anything to do with understanding natural language. So that's the understanding, the generation, and there's whole subfields within NLP of that. And some people would say NLU is a subfield, NLP is a subfield of NLU, and I don't get into that debate. But because of large language models, NLP is not going away. But think of understanding and generation as two sides of the same coin. Another question we have here is, what's the difference when I upload my data information documents to an LLM model kind of give it context exactly. So what I'll do is I see a ton of questions here, which is great, but there's a lot of answers to these questions contained in the slides, and I know we started late, my fault entirely. So let me get through some of the slides because they're going to answer some of these questions, and then we'll go back to the questions and then answer them because we'll let the slides kind of speak. And we are making these slides available to you, by the way. All right, so let's take a look at the RAG stack because this will explain some of these questions. So when we look at a RAG stack, first question you have to ask yourself, what's the information we're using in RAG? So first set of information, as we've already kind of alluded to, is structured information. So data warehouses, data lakehouses, relational databases, SQL servers, Oracle servers, anything that's got structured data can access this. Then, of course, unstructured as well can also access this. So you've got MongoDB, good example of a NoSQL database. Data lakes and data warehouses also can store unstructured data. Is another example. Also think about semi-structured data. So data that might be in a JSON format. Another great example of semi-structured data is website data. Like why is OpenAI able to scrape the web now? Well, it is kind of almost in a semi-structured format. So if you look at any HTML page, you'll see it's got tags and dividers in there. So that's a kind of a big deal that we have the semi-structured data. And then a very large part of this is programmatic data. So that's anything we would say that's attached to an API. And a lot of this API data comes across as JSON data. So there's APIs out there for financial services, for healthcare, for travel, for anything you can think of. There's already been an API built around it. If you look at companies like Zapier and UiPath, they help you build APIs around stuff that does not have an API. So look at all the financial information, the banking information. How are you able to use all these apps that can go out to hundreds of different financial services because they build APIs in this, right? So the first question in RAG is, like all of AI, you need data. So the data comes from these different sources. And there could be other sources. Like you could plug this into social media if you wanted to pay X, whatever it is now, $500,000 a year. And then we pull these into data processing engines because, again, machines don't like data in raw format. They have to be converted into something that is machine readable, and we'll talk about that. So there is some data processing and some transformation that goes on. And then a big part of this is what we call our index. And we're going to be spending a lot of time talking about an index because indexes is where think of an index as almost like a database. It's the central storage component where data is pre-processed and organized in a searchable format, right? So if you know anything about a database, have you ever been to the library? What do you use in a library to access all those books? You use an index, right? What do you use in a database? If you want to speed up your information retrieval, use an index, right? Not quite the same thing, but this allows for fast retrieval for user queries. Now, the stuff we store in there, we're not storing books or we're not storing raw data. What we're doing is we're storing embeddings, and embeddings are a special thing that we'll get to a little later. But what we then have is once our index is built, we have this kind of a user here. And remember, users in AI, it's not just text now running out of text. It could be speech. You could be uploading an image. It could be controls. It could be IoT. It could be some kind of a trigger event. But something is going in there. It's going into some kind of a large language model. It could be this could be Mistral. It could be Gemini, Gemma, OpenAI, Llama 3, 5, Cohere, you name it. It does that natural language understanding, builds that query, and then generates that response. But remember, that response is this is going to come back in the form of embeddings and values that convert into probabilities, and then we have to convert that into text using our large language model again. And that response goes to the user. It could be spoken, it could be text, it could be an image, it could be a report, whatnot, right? And there's 5 stages to RAG, which we can talk about. The first is the loading and acquiring of data. Ali's going to give you a simple example of this, but this is just bringing information wherever it may be stored. And again, anywhere data can be stored or access to, your RAG system should be able to access it, right? Now, of course, that means it can't access stuff it's not allowed to access. And we can talk about privacy and all that stuff a little later. The next part is, as we just mentioned, we need to convert that data into a searchable format. And most often that involves something we call vector embeddings and generating those. And again, we have an example. Ali will show you how that works and give you an example of that. And then there is a difference between generating those embeddings. So imagine we got a bunch of text, we convert that into embeddings, and now we got to store that someplace. So where are we going to store that? We have to store it in the store. There's a number of different tools we can store that in, such as Pinecone, Weaviate, Milvus, LangChain. We'll talk about those storing of those. And then now we've built all that, now we can actually run queries around that. So once we've done this first three, we can query these. We can retrieve the most relevant information from that index data, and that's past our language model. And the last part, as there was a question about this, retrieval is very, very important because we've gone from naive RAG to quite sophisticated. So we want to, because one problem with the existing systems was with enterprise search as it exists right now is it's kind of like a Google search. Google try and gives you back the most relevant pages, but you want to be able to rank the results, right? How do I know they're accurate? How do I know my relevancy score, my accuracy score? How do I know that the documents in there are not there? Like an example we always use called needle in a haystack. Let's say you have millions of documents, and then one of those documents on the 54th page and the second paragraph, third line, there's this piece of information. Are those systems really good at getting that little piece of information, that needle in the haystack? Enterprise search, the existing enterprise search is not good at that. LLMs are getting better than that. So we have a whole slide on evaluation, and we'll get back on that. And that's very important. And fidelity here means, again, it's not hallucinating. It's being true to form. All right, I'll take a few more questions, see ones I think we've kind of answered in these slides here. Sorry, trying to go back above these. So question, can you give a sense of how effective RAG is at reducing hallucinations? It's not, in the sense that there's no magic solution by itself. So first of all, hallucinations can happen in the LLM itself, right? And RAG will reduce hallucinations in the sense that, let's say, if I'm given a set of documentation around healthcare, eye care and healthcare, right? And new information that wasn't there. If it has this set of information, so someone asks us a question around, like, okay, I just went in for some eye care. I had a special procedure. Can you give me information about this? If there's more information that you're providing with that it wasn't in the original model, that can help reduce hallucinations around that, right? So that's number one. Number two, you still, within RAG itself, to reduce hallucinations, you have to apply all the hallucination reduction techniques that you would apply to an LLM. So different ways of doing that would be doing your own evaluation on your own system, right? There's ways of doing that. RLHF, reinforcement learning, human feedback. Ali and Sharif and Daniel have built a system for this, where when we ask our agents a question, we give a thumbs up, a thumbs down. That's one thing. You may also have heard of a procedure called, there are different benchmarks you can use out there. A good way of testing and evaluating, there's an open source project out there called Phoenix. It's from Arise AI. It's an open source project called Phoenix. We've used it. That's pretty good for testing and evaluating. And because when you say reducing hallucination, that's kind of like one part of the test stack. So it has to be kind of built in there. And another interesting way for reducing hallucinations and testing RAG and LLMs in general is also AI as a judge, or large language models as a judge, right? So the way to do that is, like, you might take another LLM or fine tune that for a specific use case, but using the LLM to critique the LLM. And I know it sounds weird. Like, why would you use a probabilistic non-deterministic system to test another probabilistic non-deterministic system? Well, one, you can fine tune it, and two, with zero-shot learning, having one LLM query the results of another LLM and validate that response is is an interesting way of doing it, and that's very popular. And then another way of doing this, which gained a lot of steam, is there's a lot of projects out there called we would call them generally guardrail projects. So you may be interested in, like, you don't want your LLM to swear, or you don't want your LLM to answer certain questions, or you don't want to be your LLM to be used for bad. Like, how do you test and evaluate for that? Well, there's open text is one project, open source, guardrails. There's a Microsoft project called Guardrails out there, which I believe is free. There's also a startup called Guardrails, and there's at least a dozen startups around this testing and evaluation. And I would say we just hosted ODSC West last week, and evaluation was the hottest topic there because, as Ali will show you, it's very easy to build these RAG systems, but the evaluation and testing is still the hardest part to it. So that's a great question, by the way. So sorry, there's no one simple answer there, but these kinds of things keep us employed. These sophisticated systems, but it is getting quite difficult to evaluate these. So I think I answered the question too about testing RAG will work. Chatbots, yeah.
There is another question related to searching through a large vector database and if it does pose significant latency in the RAG model. And I think, yes, this happens. It depends on your vector space and what are you basically searching in. So techniques like the trunking, the good embedding, and using a suitable vector store, and limiting the number of the documents that you're trying to retrieve through your search might make the latency a little bit better and not make it that late in terms of the LLM or the RAG response, which is one of the stuff that people usually complain about. And when we started, remember, Seamus, one of the complaints we had, like, our AI assistant were taking so long to respond to simple questions
Yeah,
because of mainly the search space.
yeah, we can look at a few solutions for that. But again, that's latency is pretty complicated as well. And Ali, I think you can explain that as well when you're showing your use case. But that's a good points. Yeah, so let's move on to the slides because again, Ali just mentioned chunking there. We're going to talk about that, but and a key thing to understand here is indexing, because remember, indexing is supposed to be the holy grail of making things fast and responsive. But as Ali mentioned, it still is there still can be latency caused by that. And in terms of indexing itself, to understand what indexing is, the idea is we would want to transform our data and documents into a searchable format, converting them into embeddings, which are vector representations of data. So one thing I'd say is pay close attention to these next few slides, because a lot of things around testing, around latency, around performance kind of directly relate to this. Because as Ali's alluding to, it depends on how you build your index, what you use to build your index, what you include in your index, and then what your use case is and what you're looking for, right? So data transformation is the idea of converting this data into embeddings, and embeddings are pretty simple when you think about it. It's a numerical representation that captures the semantic meaning of text. This enables what we call a similarity search, where the system can find data points close in meaning to a user query. And this is very important here. We had to cut out a slide in this, but maybe we should have left it in. So imagine trying to map something in two-dimensional space, right? Like, let's say you have king, queen, man, woman. You would see in the two-dimensional vector space that man is closer to king and woman is closer to queen. And if I had person and royal, then we'd see royal is closer to king and queen than it would be just a normal person or a boy or something like that, right? Or a girl. So much like that, we're able to embed this similarity search, and there's lots of different techniques around this. I think we're using FAST in Ali's example to do similarity search, but you have cosine similarity, of equiline distance similarity, and basically it's a simple concept. If I map something on a high dimensional space, how close are they together? And the closeness together will do that query result. So if I was querying an example of saying stock prices And all of a sudden I'm seeing NVIDIA because there's been a lot of news about NVIDIA and stock prices. So you see there's some similar. And the other thing to understand as well is like we're dealing with very high dimensional data here. And we talk about high dimensional data, think about we can, if you include time, we can perceive 4 dimensions, right? So but when we're talking about systems, they can do very high dimensional data. They can do thousands of dimensions or millions of dimensions that we can't even conceive of or map. But it's just it's basic matrix math where you're taking in this similarity, you're baking that into this numerical representation, which is an embedding, and that word or phrase can actually have context and meaning around all the other words and phrases in a given document. That's what makes indexing and embedding so powerful. And these have been around a while. Like BERT is a very old one, not old, but that's been around 6 or 7 years, and can convert these sentences, documents, or phrases into vectors. And generally, what we do is we store the results of these embeddings into there's literally dozens of different stores out there. Weaviate, Novus are purpose-built open source vector stores, but also now Oracle, SQL Server, Postgres also have vector stores, and frameworks like the LangChain, which you'll see have a vector store as well. So this kind of answers a question and what Ali alluded to. So, and you'll probably have more questions about this, but if for your RAG to work, you want to use high quality pre-trained model for embedding that aligns with the domain, right? So there's lots of different large language models out there, but if you can get, let's say you're doing a healthcare RAG, it's doing a chatbot for healthcare, or let's say you're doing a large language model for something like advertising or marketing or sales or writing. If you can find a large language model out there that fits this domain, number one, or is fine-tuned to serve that domain, that is very important. Because remember, these large language models, what do they have? They have pre-trained embeddings. So all that's history to know, whatever they scraped off the pile, whatever they scraped off Wikipedia, those are converted into embeddings as well to create that foundation model. So that's one thing to think about. And then you got to do some experimenting with dimensions and indexing methods, right? So a lot of our time is spent playing around with different kind of indexes, different kind of vector setups. When we started using Weaviate, we were doing it locally, and then we started using it in the cloud to get better performance and better results out of it. So even though you may know the issues in the tools, it requires tweaking a lot of these different tools to get optimal performance. And something that we still struggle with, testing the quality of embeddings by checking if they capture meaningful relationships with data, right? So sometimes we have clients we're dealing with where they're the domain experts, and we're relying on them for feedback as to how it's working. So again, very much an old business problem where you're building it. It's not like building an app or something like that where you have very clear requirements. Sometimes, like, I don't know what's working until it's kind of like a very mushy thing if it's working well or not. So you need to build systems around that have some kind of form of ground truth. And again, if you use systems like Phoenix from go look it up on GitHub, you can test these models out by putting in things like the needle in the haystack problem. There's different scores, different benchmarking you can use, which is beyond the scope of this talk today. But there's a lot of different benchmark methods. And the main thing to remember about that as well, come up with your own benchmark methods. Let's say you're doing a chatbot around your healthcare data. What you would do is you build up this what we call the goal set. You come up with a bunch of questions and look for the answers. And now Ali's going to show you a very simple example of that, where we ask our RAG a question and then see how well did the answer match, right? So don't despair. There are ways of testing this, and it'll be in our code notebook. Another thing Ali alluded to was chunking. So you'll see in our code notebook, I think we're using 3 or 4 documents. At least the version that Ali built that I was using last week at 3 or 4 documents. And all of a sudden, now we're using 194 documents, or almost 200 documents. And the reason why, to help us improve these documents, what you can do is you can chunk them down into smaller sets, so they're better represented in the embeddings and so on and so forth. So you might take one document and chunk that down into 20 documents, take another document, chunk that down into 10, take another very long document, chunk that down into 50, right? So again, Ali will show you examples of that. And then we have these different embedding sets based on that. And this can help with performance, can help with accuracy, can help with recall, all kinds of different benchmarks and metrics. And as I said here, key for performance and accuracy. But again, there's no magic number here. You got to experiment with this because it depends on the documents you have, the distribution of documents. Do you have a bunch of very large documents and a bunch of very small documents? That kind of might be a challenge. So no one except yourself with experiments can tell you what's a chunk size is too big or too small. And yeah. So let's talk a little bit more about embeddings before I take more questions here, because I want to be mindful of time. So embeddings, because this is really key to understanding how a RAG works. So it's a term used to describe a set of techniques, as we mentioned. It captures semantic relationship, meaning interpretation across words. And these are what we call dense vector representations. So if you ever looked at a vector, it could be made up of just binary vectors, 0 and 1s. And if you had what we call, let's say, 1,000 dimensions, you would have think of a spreadsheet with 1,000 columns of 0s and 1s. And there will only be one of those columns will be set to 1, the rest are 0, right? So that's low density, but these high density ones are using kind of like floating point numbers, and they can represent lots of different dimensions in a single vector matrix. And the embeddings themselves can be used for search, chat box, expert systems, and many more things. Why? Because they can do keyword phrase, document search. They understand the meanings, the context, and they understand the relationships and the importance of different words in a given context. There's a platform called Mnemonic AI. This person has spoken at ODSC a few times, based in New York still, but check that out if you want a visual representation of what embeddings look like. He's got some pretty cool open source tools around that. And for the embedding models here, you might know Word2Vect. If you just want to learn embeddings without getting too deep in it, study Word2Vect, because that's one of the oldest, simplest one. I give an example here, King Queen, and Bert is from Google, but one of the newer ones we know is OpenAI Ada ones, and that's the one that Ali's going to show you. And then I'm going to skip through this real quickly because again I'm sensitive of time and want to get to Ali's notebook, but think of it in 2 steps when we go to this embeddings layer. First, we do tokenization. So OpenAI's got a nice little tool where you can see how you convert words from tokens. But think of tokens representing 75% of words, roughly translated. And then those tokens are vectorized. So that's where they're mapped to that high dimensional space. And that's each word is mapped to that high dimensional space. So let's say you had 1,000 dimensions. Each word is going to have a representation with 1,000 dimensions in it to capture context and relationship with other words and phrases and stuff like that. I talked about that as well. So one thing to kind of understand, just to bring this together, is like why are large language models so powerful? Because they have these pre-trained embeddings, right? So we took all that knowledge from the web and other sources they scraped it from, like the Common Crawl, the Pile, Wikipedia. All those words were converted into tokens, and all those tokens were converted into a type of embedding. And now those embeddings can be fine-tuned for specific applications, including RAG. So when people talk about fine-tuning a large language models, they're really talking about adjusting the weights to emphasize different parts of its understanding and learning. And again, these embeddings capture these nuanced relationships that can help RAG match the user's intent with high accuracy, even if the phrasing differs. And this is why what makes large language models so powerful. I could ask it the same question 10 different ways, and because it understands those nuanced relationship between words for a given language, English or French or Hindu, whatever the language is, it can still understand the context and the nuanced understanding of it. So what that means is we can do similarity search, we can do contextual accuracy, Are we understanding what the context is? A huge part of this, of course, is transfer learning, where we have a model was trained on one set of embeddings. That knowledge, without retraining it, can be passed to another model in the form of weights. And if you don't understand what I'm talking about weights, go to AI plus training. That's usually what we're talking about. There is deep learning, and for the most part, large language models use what called FNN, or feed forward neural networks. Um, and also we can apply this across lots of different domains. The storing part. So once the data is indexed and converted into embeddings, we store this in different databases. You can use the metadata can be stored in a SQL database. That's kind of important as well. And then best practices: use metadata to improve retrieval speed and relevancy. Use version control, ensure data storage, and then three of the storing ones three of the vector storage systems we recommend would be Weave8 and Milvus. These are free and open source. We use Weave8 in a lot of our platforms. Pinecone was kind of like one of the original platforms. It's a paid service, but I know they're always improving as well. But also you can use Postgres and other systems as well. So I'm not going to spend too much on storing because, again, and the nice thing about some of these platforms, they come with a wealth of knowledge themselves, because if you start using Weave8, they will teach you a lot about RAG, or Milvus is the same, and Pinecone is the same. Ranking is very important, because one big problem with existing enterprise search is it's giving me back lots of given documents, but I want to know what's the most important part of that, right? So ranking and re-ranking, and it's technically re-ranking because the results come back from some kind of a system, and now we need a ranker to re-rank those and say, given the user profile, given the query, can you rank these responses and prioritize them in the most contextual important information as possible. So how it works is you have retrieval, storing, and ranking. Then we select the top K results. It could be the top 3, top 5 results, and then a response, right? And you can see this is where a lot of testing and evaluation is going to come along, because how well are you, first of all, assuming you're getting access to the data and it's pulling back the right data. Like if it doesn't even pull back the right data, no point in ranking the wrong data. So first, the recall has to be quite good, and then you're trying to figure out the ranking and tweaking a lot of that. So a lot of work in RAG systems is done around this ranking. So ranking is very, very important, because from a user perspective, when you get a lot of information, the re-ranking is really going to tell you how well the system is meeting the user's needs, right? So one way of doing that is this embedding scoring. Again, I mentioned cosine similarity. This is a very common similarity score. There's other ones like equiline distance and even more sophisticated scores than that, but that's one. That's kind of like I would consider a base model. So if that's not working for you, you might want to consider a different kind of similarity score. Transformer-based re-rank models. These might be a little better, like BERT and cross encoder. And again, don't have to worry too much about these. For the most part, these are parameters or settings within your code, because you're not building these from scratch. And then something that's starting to get quite popular now is these hybrid re-ranking approaches, where depending on how sophisticated your query is, you might want to use a mix of different systems depending on the context. Because imagine like you had a system like one RAG application might be a chatbot for customers. Another one might be internal documentation where it's more private information, and you might want to use a different re-ranking model for that. And then another one, which I haven't tried myself, but there's some research in that, weighted scores, where you kind of weight the scores in the ranking to kind of adjust the weights to adjust the ranking. Like what you use to weigh that is open for interpretation. And again, beyond the scope of this, but that's a pretty sophisticated method. Mainly because if you do it right, it will work well. If you do it wrong, it's going to make your RAG much worse. Quickly go into RAG tools and frameworks. So you're asking, like, how do we build these RAG systems? Well, luckily, there's lots of different things out there. You have your proprietary LLMs, which I'm going to skip through real quick. You've got Gemini, OpenAI, Anthropic. And these are paid models. Then you have your open source ones. They're not as performant, but if you have private data, because there's a question on this, like, do you really want to be, like, you're probably not allowed to send your customer data up to OpenAI or Anthropic or Gemini, right? you don't want to be using these on a sending private information up there. And I know all of these are giving you local or on server or on-prem solutions to this, or scrambling to do that. But the open source ones are Llama 3.5, Mistral, and I think that should be Gamma from Google as well. So those are a few there. So you've got lots of choices. But again, I think the two big things here are performance and privacy, right? So if you're looking for performance, these models kind of tend to be ahead. The proprietary ones. If you're looking for privacy and concerned about where your data is going, then you need to store these on your own secure server, like putting this on a big cloud server provider where it's not secured is just as bad, right? Maybe you want to store it on your own local laptop, your workstation, and stuff like that. So this helps you figure out the privacy issue and the performance issue. And then in building these frameworks, orchestration is something we talk about. Like, how do we build these? Imagine an orchestra with lots of different parts in the orchestra playing, the saxophone, the cello, the violin. So we need these frameworks and tools because they do the heavy lifting. They pull together this orchestra of various tools you need. So we have a retrieval layer for getting that information back, going to the vector database, doing similarity search, and then we do orchestration layer, which controls the routing of this information, right? So we threw up a few charts there, but how do we retrieve that information? How do we build the embeddings? How do we get that information back out, do our evaluations and all that stuff? So this is our retrieval orchestration layer, and testing layer can be built in that as well. And the tools that I tend to use are Llama Index. Another one is getting better is LangChain. It was quite buggy when it came out, but it's improving, and that's the one that Ali's going to show you around. And the last slide we're going to go to is the second last slide is evaluation. So the things we care about when we evaluate RAG are accuracy, fidelity, and response time, and overall user satisfaction, right? User satisfaction, again, how we've been doing that is just ask them thumbs up, thumbs down, rate us out of 10. Response time is a big challenge, as mentioned. Fidelity, meaning how accurately, how well does it retrieve the information, right? Does it solve the needle in a haystack problem? Is it parsing all of your documents in the way it should be? And accuracy speaks for itself. So I think I spoke about all these. So human evaluation for evaluation method, automated metrics, the blue score. Blue score comes out of NLP, by the way. A/B testing is very important. Different embedding models is kind of key. I kind of skipped over a lot of evaluation methods. Again, check out Phoenix. Building up a gold test standard. A/B testing is kind of what Ali's going to show you. You have a question, we've already got a response, and we match the response that we expected versus the one it gets. But that's very important. And then best practice. As always with machine learning and AI, check for data drift, check for model drift. So you always want to be looking for user feedback loops. And here's our kind of summary here, which I want to lay out from the whole screen for you. So user query creation. We do our tokenization and then our embeddings, and then we do our index search and retrieval based on our vector database, and then we pass that back to the LLM. So again, I know I went through that quite fast, but I do want time to give Ali and myself to answer these questions. So Ali, any questions you want to answer, or I should answer before we go to the
Yeah, some people were asking as well about some RAG evaluation frameworks, and I think you mentioned Phoenix, and there is as well if people are using LangChain. Langsmith provides a really good evaluation framework, monitoring, and yeah, it's really sufficient when it comes to using LangChain.
Yeah, and if you go to evaluation in GitHub, there's a never-ending stream of evaluation frameworks. But I think
Yes.
too many is not an answer. But I think the ones Ali just mentioned are our favorites.
Yeah, and always like a rule of thumb when it comes to evaluating is, as you mentioned, to start with the small stuff. Like, does the output make sense? Does it capture the same context as the question? Is
Yeah.
there granularity? User feedback is very, very important because at the end of the day, basically what we're building is new stuff. It's not tested. It needs some human intervention.
Yeah, and I would say, like, I know some of these answers may not be satisfactory because they are kind of complex. We are dealing with complex stuff here. So I would give you a piece of advice and a self plug. Check out our podcast at odsc.com/podcast, because we actually did have people from the Phoenix team talking about evaluation. I think we've at least 3 or 4 evaluation podcasts on there, as well as building and testing LLMs. And a few pieces of advice that I've gotten, which I wish I'd taken because it was kind of too late. Number one was start with the best large language model. So let's say I'm not a fan of the biggest, most expensive model out there, right?
Yeah.
But start with the best model out there, right? Well, I'm not going to pick favorites, but all right, let's say Anthropic or OpenAI are the best out there. Even though you don't want to use those because you might have privacy concerns, right? But
Exactly.
use those to build out how well this can work for us. So you start with that LLM with the understanding that you'll switch it out to another LLM that actually suits your production use case, which could be a privacy preserving one, right? But start with the best LLM, number one. Number two, don't throw your whole database at this. Don't go and embed thousands of documents. Start with a small known set that you can easily test, easily evaluate, right? And I would tell you, like what Ali's about to show you, if you've never done this before, take that notebook and use that as your first test. Take 5 or 6 documents or a dozen documents or a couple of hundred documents and build out with that. Don't go and say, okay, the first step is we got to get all our documentation from everything from the source. Start with a use case, and that was another problem we did as well. I hear a lot of people building it and they will come kind of idea. No, spend a lot of time thinking about the use case, because if you start off with a hard use case, it's going to be a hard problem. Start off with a simple use case, like think about something you may already have, like an enterprise search for, like it might be, let's say, customer retrieving FAQ system, right? Frequently asked questions. Pretty basic.
Exactly.
FAQ systems kind of work crappily. So build a RAG system that, and then see looking like, well, yeah, how well is it performing? And evaluate that and get used to that. Don't tackle a big system, because time and time again, myself and Ali and the rest of the team have learned that lesson the hard way. So any other questions we should answer before we go into?
I think we
Yeah,
can start with
yeah,
with the notebook. It's gonna raise some more questions.
yeah. Just Mel answering a question, like she's saying, in her experience, still hallucinations. Yeah, Mel, absolutely. And the problem with hallucinations is they're getting harder to detect, right? Because the models are getting better, but better mean they're more confident in how they're wrong, right? It's like how, let's not talk about certain stuff, but
Mhm.
it's about trying to convince people when you know they're wrong, but they can't convince them. Like large language models are becoming like that. They're becoming better. Because in the old days, oh, I'm sorry, I realized I was wrong. Sometimes I challenge the large language models, like, no, it still thinks it's right. So that's a problem. Hallucinations are getting less frequent, but the ones that are happening are getting harder to detect, I would say. Yeah, but let's go to notebook because we shouldn't.
Yes.
Um, do you have access to control? Share your screen, Ali.
Yes, I think so. Can you see my screen now?
It's coming up. Yeah. You may want to increase the font size.
Okay.
I'm going
No,
to remove myself from the so I can
no,
give you more room, but I'm not sure if I can remove myself.
no, I don't think so. Is it showing right? Yeah, perfect.
Yeah.
Okay, so keep in mind, guys, we're trying to build a very basic thing here. As Seamus was mentioning, it's like the building blocks that you can play around with. And yeah, you're definitely gonna get a copy of this notebook at the end of the session, and you can just use the building blocks and change whatever you want. If you want to change vector database, if you want to change the LLM, if you want to add your own evaluation model, that's totally fine. you're just going to get a copy of this and you can use it to trace and build something on your own. So basically what we're targeting here today is building a very basic RAG system with the concept of re-ranking as well, using and based on some PDF files. So in this notebook, when you get started, you're going to need to get your own API, Open API key if you're going to use OpenAI large language models. You're gonna need to get the Cohere API key if you're gonna use the re-ranking model as well. And I'm gonna go in depth about the re-ranking and why it might be useful and decrease the hallucinations as well. So we start by basically installing the packages that we need, which is LangChain Community, OpenAI. All is documented and it's added for you guys. And basically, when you have your keys, this is a way to access and add your keys into a Google Notebook. When you get a copy of this one, it's not going to contain any API keys. You're going to have to come here, add your own secret, and that's it. And basically change the name or use the same names. So this is one is for Cohere, and this one is for OpenAI. So we get an initialized environment variables, add our own API keys, and the first step we talked about and Sheamus mentioned was doing the data loading part. So basically here we have a research paper talking about the LLMs and using LLM models in the medical field. So we're gonna use this one as an example of how can this be relevant in terms of building question-based system or some sort of summarization for a company's documents or an FAQ for a company document, stuff like that. So here we're basically building a small function which goes through any PDF document in this and just loading it as text. And if we do this, you're going to see that it just prints the first 500 characters from the documents. And how many characters do we have? We can see that we have around 73. Okay. So this is the first part. This part can definitely be used like this and just uploading some PDF documents, and you can use your own PDF documents, or you can replace this whole part by maybe connecting to an API endpoint or connecting to a Postgres or a MongoDB database and streaming or getting the data from there and then passing it to the other part. And the other part we mentioned and we talked about is indexing and text splitting and chunking. When it comes to chunking, as Seamus mentioned, and as I mentioned as well, why chunking is important, because we're trying to limit or break down the number of texts that we have. For example, for here we have 73,000 tokens or characters, which are not going to be too great if we just shove everything into a database and that's it. And when we try to search for something, this is going to be your search space when it comes to it. And when it comes to dealing with the database or a huge number of documents, chunking is going to be a very, very good approach so that you can have chunk data with some sort of a context, and then you can store into your vector database. One of the chunking mechanisms that LangChain provide is a recursive characters text splitter, which in this case, it doesn't do the chunk specifically as it says. So I have here, for an example, we're using 1,000 characters as a chunk size, but it doesn't specifically chunk them to the 1,000. If we go down here and see, we're going to see it has 959 and 196. Why? Because it takes the context of the word, punctuation, stuff like that, so that it doesn't break the meaning of the sentence you're chunking. Some other text splitters are just going to chunk based on your chunk size. This one is a little bit better because it keeps track of the commas, punctuation, stuff like that. So the text would make more sense. Also, we try to add some sort of a chunk overlap. I have seen some questions related to some ways of smart chunking and adding a chunk overlap. Chunk overlap is important so that you still have a context in all the documents that you have been splitting. You don't want each chunk to have its own meaning. So basically, you try as much as you can to have some sort of an overlap. These are just some default numbers. You can start an experiment with them, see what suits you based on your data and your application that you're trying to build, basically. And yeah, so if we see here, we try and chunk the data and we see that we end up with 83 chunks. This is the first chunk, and this is, for example, the second one. And if you see, this is basically, this part is repeated all around here because of our overlap. These are some type of commonly used text splitters in LangChain. We're using the recursive character text splitter, which I said it has specific boundaries and maintain context across the splits. There is a character text splitter as well, token, sentence, and you can use some of the NLP based one. Again, it's based on what you're trying to do and how complex is your application. Before going into the embeddings, is there any question? Okay, so far so good. Okay, so now to the embedding part. And as we explained, embedding is very useful in turning your text into vectors. So it's going to turn into basic numbers, and these numbers are going to be useful after that in terms of doing the search. And the search here is going to be like it's gonna make it more fast in terms of your the way of your search and the basic databases that you can use as well when you turn your basic texts into an indexes and into vector a representation of it. And as we mentioned, there's different ways of embedding and vectorization techniques. But here, for the sake of this, we're just going to be using OpenAI text embedding ADA 2. Again, you can switch this and you can see how would this affect your data embeddings. Would this actually make it any better or make it worse? Just to give you an example of how the embeddings would look, it's basically numbers, and these numbers represent um, the text, our text. It can be done on images, it can be done on any type of data. Basically, we're transferring this into the vector representation, which can be used later in terms of similarity search. Then, for the sake of this, we're using Face database, which is provided by LangChain, and it's an open source vector database provided by Facebook. It's very simple. And when it comes to using any vector database, it doesn't only matter what data you're providing, you need as well to provide some sort of a metadata and make sure that the metadata is relevant so that you can enhance and enhance at the end of the day the results. Okay, so here just a number of documents and sample vector from the vector space that we have right now. Okay, so this part, what we basically did is we have a face database and we passed our documents and we passed our embedding models. This is to be able to get the indexing of the data. Then we're just gonna add this data and save it locally so that we don't have to go back and do the embeddings and the indexing again. In this part, simply we're just gonna load the data that we indexing into our vector store, and we're then gonna go over and just use this in retrieving the data and start building our RAG system. Basically, what we'll need is after you get the indexing of your data, you will need a retriever, and the retriever would be basically the object that you will pass into your index, and you're going to use some sort of a search type, which in our case is going to be a similarity search, which can use the cosine similarity or the Euclid similarity, and we're going to add some arguments and saying that we're looking for the top 6 documents that might that are similar to our query, or basically what we're searching for. And if we go here, basically we loaded our vector store, and we have our, let's keep this to 6. Here, for an example, we're trying to find what does the paper discuss, or what are the topics related to the paper. If we go here and we use our retriever and pass this query to it, this is just basic similarity search. We didn't use any type of LLM or anything. We're just trying to do some similarity search. What you're gonna get here is basically 10 documents based on the vector search that was done on this. And if you start looking at them, document 1 says it's deployment, assisting role, improve efficiency, models can be blah, blah, blah. Basically, what we have got doesn't make sense because it was mainly based on vector similarity search. But if you combine this and add it into an LLM model, basically this is the top 10 documents that you have that you think, or your retriever think, or your system thinks that are related to your question. Then what basically RAG does, take these documents, pass it alongside with your prompt and your question into an LLM model like OpenAI, and then it should be giving you the answer based on these documents, which is different from the stuff the normal API LLM does, like ChatGPT or stuff like that. Because at the end of the day, you're passing in your own data, or at least chunks from your own data. There is some context to it, and there is a basic question that you would like to answer. But one of the new and really good stuff here that we can add as well, that can reduce the hallucinations and can reduce and can actually enhance the output, which would be a re-ranker. And a re-ranker would be a model that you will just pass into the 10 or the top n documents that you have found and the query, and it should be returning to you the top k documents that are actually most related, or related to your context of the question. In terms of just applying the similarity or the cosine similarity to it, it's just gonna, in this situation, a ranker like Cohere ranker would apply a sort of a context similar to it. It's gonna take the context of the question and that context of the documents, and it's gonna return the top K, which is might be 3 or 4 documents from the original 6 or 10 documents that you sent that were the result of the similarity search. Here, basically, since you've used your API key, you're just gonna initialize your re-ranker, and we're gonna use from LangChain, we're gonna use the compression retriever, which is basically gonna combine your old retriever, which is the base one that was using similarity search, and it's gonna combine as well your Cohere re-ranker, which is your let's say advanced retriever, which is basically is using the model English version 3 from Cohere, and we're saying we just want the top 3 documents. And here in this scenario, when we combine this and we just want the top 3 documents, we're gonna find that at least the results are much better when it comes to it. So these are some of the documents that resulted from the combination of the top 10 documents from the similarity search and the top 3 from the re-ranker. And if we take a look, we're going to find out that they're definitely they're not the same, at least in terms of the ranking of the documents. So after that, we can basically use this composite retriever, which uses the re-ranker and the base retriever, and we can, using a simple initialization of ChatGPT LLM, which is going to be ChatGPT 4, you can change this to 4.0 or 3.5, whatever you want to do. And we can use as well here, we have two parameters, which is the temperature and the maximum number of tokens. When it comes to temperature, the temperature is basically between 0 and 1. And when it comes to it, if you go with 1, or it's going to have its own way of improvisation and answering the question. If we go with 0, it's going to be so strict, and it's going to basically answer based on the text it was passed to it without any edits or any hallucinations. But at the end of the day, you're going to get a very basic answer, and most probably not the answer you were looking for. So we're trying to set it to 0.5, which is the balanced temperature here. When it comes to token, we're trying to say and limit the number of tokens in the output from the LLM into 300. And tokens in terms of input and tokens in terms of output are gonna affect, of course, the cost of your model and the cost of using OpenAI APIs. So some techniques would be adding a maximum number of tokens in the output, and some other techniques would be text pre-processing to make sure that you remove any punctuation, any of the stopwords, stuff like that, and you make your input as concise as it can be yet good enough for the output. Here we're just building the chain, and we're initializing a retrieval, and we're giving it our large language model object that we initialized, and we're giving it our retriever that we initialized here that has both the retriever and the cohere re-ranker. And this would be basically, here we have a user query, which is so basic. What are the topics covered in this document? We have the prompt, and based on your prompt, it's going to affect the way that your RAG system answers the question. It can be just basic answer, or it can be answered in a specific format with some insights, some links if you would like. So mainly you can test with this prompt, play around with it, and see what kind of output you are expecting. So for an example, if we would go with this, what are the topics covered? You would see topics covered in this context include limitation of language models and how they can overcome. So basically we got and ended up with a very concise answer that represents and reflects actually some sort of a summarization for the document that we passed, which at the beginning was basically like this. And that's it. You can use here to keep chatting this function you can play around with, and you can chat with the data. And in this part, this is mentioning the evaluation. This is a very simple evaluation example. We're basically using a Jakar score, and we're giving our model two types of questions and some expected answers. And we're basically here trying to see and calculate the similarity between these answers. This is a very, very basic type of model evaluation or answer evaluation, but more sophisticated stuff can be implemented using monitoring and evaluation platforms would be recommended. We mentioned Phoenix, we mentioned Langsmith. So these types of evaluations definitely would be recommended, specifically when you're trying to build something that would go for production grade deployment. Let's see. Yes, you can definitely try and use some hybrid search based on BM25 or cosine. That can be good. And you can play around with some word to vector similarity. That would be good as well. Some other OpenAI, I think, have their own re-ranker right now, so this can be used as part of the re-ranker.
There was a really good question from, I think it was Mel. It's a question we get a lot, and that is
Mhm.
you know, can we how do we add new information? How do we add information in real time or new information to this, right? So yes, that's the whole idea of a RAG. Like unlike a foundational model where the embeddings are pre-trained, you need to be
Mhm.
able to update that and more information. So how you there's a number of ways of doing that. So first way determines on what kind of vector store you're using, right? Fast, Chroma, Pinecone, Weaviate, Novus, all that stuff. So we get the new documents, they become available, and then use the same embedding model to embed those. And then
Mhm.
there's a couple of techniques in there. You want to like I can't remember what we do, but you can do anything from updating to deleting embeddings because the new information might replace existing embeddings. Um, I think you can't do that with FAISS, but you can do it with Weaviate.
No, yeah, you can do some of yeah, some other vector databases. I think Weaviate can be used.
Yeah.
From, yeah.
And then I've seen we don't actually build it, but for streaming updates, you can use Apache Kafka or Redis or existing streaming platforms like that to feed those documents into.
There is, yeah, there is another part I forgot to mention as well as when it comes to the latency and how you are expecting your model or your agents to respond. Using caching for the queries is a really good option. So you can utilize Redis and something for caching. That would be a really good option.
Yeah, and you do want to, depending on the information that comes in, you want to re-index, right?
Exactly. Yeah.
You want to re-index, and best practice there. Well, again, yeah, I actually want to say something about this because what we say is good and what actually is good in reality are two different things. So we say best practice. A lot of people are saying batch, batch, batch because why do you want to do that? Well, it might reduce costs, make things less brittle, but maybe you want real time, and batching is not a good idea because batching is the opposite of real time. You wait until you got enough information. And yeah, I see a few comments on, this is good or this thing kind of sucks. Um, Look, this stuff is, again, going back to our advice. If you're new to this, don't worry so much about what people tell you is good or bad. Like if you'd asked me a year ago, like we switched from LangChain to Llama Index because yeah, LangChain was super buggy and it was driving us crazy. And when we started using Llama, but is it better? No, like it's kind of like everything else in life. What works for you is based on a bunch of different nuanced things. Like sometimes paid is better, sometimes free, sometimes like ease of use. Like if you're an expert, then yeah, you'd be
Mhm.
using the state of the art. But most of us, including myself, I'm not building RAG systems 724. We've other
Mhm.
work to do. So there's a lot of different nuanced things to go into, like which is better, which is not better, and things like that. So again, this is just we're not endorsing any of these platforms here and saying they're better than anything else. We're just
Yeah.
giving a quick framework there. There's a question around where do you set the similarity search? Again, depends on the vector store you're using. You do it one way in Weaviate, another one in vector store using FAISS. I think the ones that they take are the electrodyne distance and cosine. I think
There
you
is
just
one, as you mentioned, yeah, one would be in the base retriever, like if you're just using without a re-ranker. So this is what would you assign your similarity, how you're going to do your similarity search. And there is another one which would be in the re-ranker. You can basically specify which type of similarity you would add in there.
yeah, I think someone mentioned Chroma. That's an interesting one as well. I would say that's slightly user friendly, depending on where you're coming from this. And there's stuff out there in the market that are I don't know. I don't want to use the word better, but it's all relative. Um, Another question that kind of came up was kind of interesting was small SLMs. I think someone answered what's
Oh,
that. So that's a small language model, and someone asked the question: Is an SLM better for privacy? And they're not necessarily built with privacy in mind, but they can be better for privacy. I guess there's a few ways you could argue that. One is SLMs are built for on-prem or on-device. So if I got a large language model running in my cell phone and it doesn't need to go to the web, then by definition, if my phone is secure, you're better off having a model running on your on-edge device. That might be more better for privacy. Same
mhm.
argument goes for you want to build a model on your laptop workstation on-prem server. SLM can host that easier. So in that sense, SLMs can be better for privacy. You could also argue that they're not. They don't need to be fine-tuned or trained in these massive amounts of information to the same extent. So less information means better privacy. Bit of a stretch, um, but um, I would say yeah, it's fair to say they're better because by definition you can fine tune and retrain an SLM easier than a larger LLM. And if you're doing that with privacy in mind, then the one that's easier to train is a good one. So I think
There is a question which is good, which says, how can I ensure that each tenant's data is secure and that there is no data leaks between them while using a single LLM? So I think in this case, it really depends on how you're, first of all, what are you dealing with? Like, are you using like one of the paid services? So in this case, you don't really know if related to the privacy and the data between your different tenants. But when it comes to your own implementation, I think this can come with by a separation of concerns. Basically, when you try and build your own LLM or use one of the open source solutions, you can control this basically on how you're streaming your data into the LLM. So you can keep track of what you're giving to the LLM based on which user is trying to use the service right now. And so I think
yeah,
encryption.
that's interesting. I can just add one thing to that because it's 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 always interesting how these solutions become very lightweight solutions and how they get very complicated quickly
Yeah.
based on existing IT infrastructure. And you see this thing now where I think so people just understand that question. I think what you're asking there about a multi-tenant rack,
Mhm.
it's also a thing now. Um, and you can have instances where different data is stored on different databases, much like you have in enterprise search as well. So you have to build these kind of collections around your vector space. Like everything is not one vector store. And then, of course, what everyone loves, aka does not like, is access control and role control. Right, certain people can
Yes.
only have access to certain data with these RAG systems, and multi-tenant is very important for that because now you're getting big back into good old role access control. But
Mhm.
remember, you don't build this from scratch. Like if you're already in a company and they built out their own enterprise stuff, these tools should have role-based access already built in, right? And then you have different controls and keys between the tenants. And then, of
As well
course,
as using different, yeah, using different databases and maybe different. I don't want to say it's not the distribution, but yeah, using different regions if you can as well. If you're having your data somewhere on the cloud, using different regions when it comes to your vectorized data would be good, and you should keep that into separation as well.
yeah, and I'm not a big believer in differential privacy. I think, like, before you go to complex solutions like that, just encrypt your data. Your data should be encrypted in transit. much like with any kind of
Yeah.
system. So
And of
yeah,
course, the data shouldn't be overlapped when it comes to doing the chunking and indexing. So you shouldn't just put everything in one pipeline and just consider that it's gonna be segregated in a way.
Ali, there's another question here. What are the best databases? I'm not going to answer that.
For what exactly? Like when
What
it
are the
comes,
best vector databases exactly?
yeah, for what? Like when it comes to vectorization, I think we said Pinecone, V8, ChromaDB might be good as a start. But
Milvus
in
as well.
general, there's a lot.
Yeah, it's again like a mix. Try and build your evaluation criteria, like best in terms of do you want free open source, do you want paid, um, do you want ease of use, what's your existing database structure? Do you already have certain database providers in there? Like I won't name names, but I've like everyone is trying to tack on a vector database to their existing database infrastructure. In some use cases, like if the most important thing is, your use case is pretty simple, ease of use, you may want to just tack it on to your existing database, or you might want to go with something like Milvus, Pinecone, Weaviate, all those many different vector databases out there. I think again it comes down to use case, right? I can guarantee,
Exactly.
yeah.
Yeah. Use case, security, privacy, and if you want to use open source or not.
So
It's big.
this is a rag hammer, right? It's a hammer, right? Not everything is a nail that you're going to hammer with the rag. So don't use rag as in search of a solution. Like if look at the use cases. If something involves similarity search, if something involves chatting to somebody where you need to go get information, um, use cases like that, then rag is a good solution, right?
Mhm.
Then once you've decided that, again, go back and look at the use case and say, okay, latency, performance, costs, all those non-functional requirements. How do they prioritize, right? If you're building this if you're doing this for your own kind of a project, something to serve up in the web, cost and maintenance an issue, then yeah, open source could be good. If this is something like I present to the clients and they're like, this is too slow, it's inaccurate, then no, I'm
Mhm.
going to spend money to make them happy. I'm going to spend their money, right? So again, I apologize. There's no easy. So you know, best is a matrix best filled out. So I think we're good, Ali. We're
Yeah, I think we're good.
good
Thank you.
question. A lot of questions. And again, the slides are going to be sent out. The notebook's going to be sent out.
Exactly, yeah.
Um, one thing you might want to explain to people, Ali, is one thing that people trip up in the notebook is you have to get yourself an OpenAI key and I believe a Cohere key, API key.
Exactly.
And
And I
you don't.
added links to these websites so that people can know where to go exactly to get the API keys. You don't have to like for Coher, you can use their free API. It's limited, of course, but you can use it. And for OpenAI, I think you'll need to pay to be able to use the API key.
Yeah, excellent.
I think we're good.
Yeah, thanks, Ali.
Thanks, Seamus, and thank you, everyone.
Thank you, everyone.
Bye.
Pleasure.